A galaxy is a big clump of stars. Ours is called the Milky Way galaxy. It's a big spiral, big long arms on it, almost like a spider. And it spins around. But inside of that are billions of stars. A star is very important in space. An example of a star is our sun. It keeps us alive, and it's way bigger than the Earth. Okay, but not all stars are the same. We see that our sun is a big yellow star. There are some stars way bigger. They're called supergiants. And then there are stars that are really, really small. One called a white dwarf, one called a neutron star. And see, they're different colors: red, yellow, white, blue. The different colors tell us how hot it is. Some stars are not very hot. Now, 3,000 degrees is still a hot star. White stars can be thousands and thousands of degrees. Our sun is kind of in the middle. It's kind of average. Okay, well, next thing we can look at is how bright a star is. Stars have lots of different brightnesses, and the brightnesses have to do with three things. Is the star close to us or far away? It turns out the sun is not actually very bright. It's right in the middle. It's average. So why is it so bright in our sky? Because it's close to us compared to the other stars, which are really far away. Some stars I just showed you are really big, so they're brighter. And stars that are really small, they're not as bright. Size, how big? And the last one, the temperature. Blue stars are usually brighter than red stars. Here you can see a star called Sirius, and it's part of a group of stars. We call this the dog star. And Sirius is one of the brightest stars we see at night. It's very easy to find it because it's so big and bright. But in reality, all the stars around it are bigger and brighter. They're just really far away. And Sirius is much closer to us. So it seems bigger, brighter, but it's not. Only from where we're at. All right, what's really cool is we can graph all of these, and we start to see patterns. Stars that are smaller and red show up in this group. And you see they make kind of a diagonal going across. As they heat up, they get brighter. Luminosity is how bright the star is. So the blue stars are the brightest ones. Here we see that there are tiny little stars that are very hot, but they're small. So they're not as bright as the blue ones, which are bigger. And then we do have some stars that are very, very bright and cool, 3,000 degrees. But the only reason they're bright is because they are gigantic. Okay, so size and temperature tell us how bright the star will be on this chart. Now, what I'm going to show you tomorrow is that stars start out as babies, then they become teenagers, then they become grown-ups, then they become old, and then they die. And if we watch it, this is where they start. They start in this main sequence, then they become giants, then they become supergiants, then they become white dwarfs, and they die. They kind of go through as a zigzag. Main sequence, giants, supergiants, white dwarfs. Okay, we will look at that tomorrow. It's called stellar, which means star, and evolution, how they change over their lives. All right, that's all for today. I'll see you tomorrow, Zoom. Have a good one.